Good day, everyone, and to Sir Elmer. My name is Sabrina Yanel Yap. I'm currently taking Math 4201 Numerical Analysis, and I am tasked to um, make a make a program for the solution to the problem. And before I show the problem and the solution and the output of the website, I'm going to introduce the package that I use for having this site. So yeah, the Shiny package is a library in R that transforms existing R code into a live app where output automatically react to a new user output. So instead of me using HTML, there is a package for this, and this is the Shiny. So all I need to do is to install the package and load the library and run an example. So yeah. Um, um if you want to actually go deeper to this one, because this is the fundamentals, I click this one, the Shiny tutorial, and it will lead to this one. So it plays here the step by step things to do for you to actually build the web app from the R script. So first need to install, and there are other templates to use, just like this one, the histogram, and this one, the loading. And it can be seen here that there are three components. This is crucial for us to read the code that we'll be showing later. So the three components of the Shiny app is the user interface object, which is the what you can actually see, the front end. The server function is the logic side of the application. So this is where I will place the code for the certain problem logic, and the function call, so that it can be prompted for you to open your website. So yeah. Um, I will be introducing the problem as well as my solution to the problem. So I am assigned to the number 4 of the problem set number 4, which is I need to find the value of y of 0.20 for the initial value problem. Dy over dx equals xy plus 2y, with y of 0 equals 1, using Miles predictor corrector method, taking that the h value is 0.05. So this is the solution that I actually did, and this is the one I will be going to place here in the R script. So here, as what mentioned a while ago, that there is the UI, the server, and the function call. So the UI fluid page, this is on a single page, and there is the title, and also I place um, the equation that will be basis for the predictor corrector. And as you can see here, I did a slider input for the inputs of the problem. There is a reason for it, and I will just show you guys later. So here, the main panel, the text output will be shown on the right side. Then for the server, I placed here the solution to the problem, but I actually changed the predictor corrector method to approximate the number of steps. In here, as you can see, this is quite a long um, method because um, I actually did this one step by step, but as it can be seen here, there are actually patterns that I can actually use. So this is the simplified method for the miles predictor corrector method. So the sentence here, this will be the output that will be shown in here on the right side. So yeah, the output which is came from here, and I will be calling the Shiny app to prompt for the opening of the site. So as you can see here, it is already a reload app. It is because I already ran it a while ago. So if I click run, it can be seen here. But since this is like a small one only, I press the click in browser. So here in the click in browser, um, it is as what I have mentioned a while ago that I did slider as the input. It is because like I wanted to prevent the edge cases. Just like for example, what if someone actually place a placed an input that is actually out of the scope. So in here I actually place the limits, so I can just slide it. So as part of the problem, as you can see here, y of 0.20 and the h value is 0.05, and you can actually see that in the predictor corrector method, there is actually 1, 2, 3, and 4 steps. So I use this number of steps, and this will be the basis for the predictor corrector, so that the the value here 0.20 can actually be used as an input, since 0.05 multiplied by 4 steps is 0.20. So yeah, if I actually wanted to play, like I wanted to like 0.02 and there's like 5 steps, then that meant like the input is 0.10, and um in here, as you can see, the output is also changed compared to a while ago when I placed 0.04 and 4 steps. Oh wait, 0.05 and 4 steps. So this is the answer of the problem that I actually answered in the problem set. So I think that's it lang, and hopefully this can be taken into consideration, that we have to look at the limitations and also the scope of the problem. So instead of like placing typing the value, I can easily just scale it up and um, have the results easily adjusted. But if you actually wanted to like adjust the minimum and maximum value as well, it can actually be done here. As you can see here, I placed the min, max, the value, and the step. So this can really just be adjusted depending on the scope and the where until where do you want to limit your value. So yeah, that's just it for me, and thank you very much.